Hi, everyone. I am Yusef. I'm from Protocol Labs, where we work on building cool stuff like IPFS and Filecoin. And today I am going to tell you about some stuff, namely how you can build a decentralized application using Web3.storage, which is one of our new services for interacting with IPFS and Filecoin. You may have heard of NFT.storage before and a similar talk. And Web3.storage is very similar, except it's for any general purpose data that you might want to store on IPFS and Filecoin. And we think that this can be a good solution for off-chain data storage and decentralized apps. But before I get there, let's talk just a tiny bit about the service. It is available at web3.storage. And it has a pretty simple HTTP API that we front with a JavaScript client, and there's a Go client as well now. This is our documentation site. The docs for the Go client are not yet landed there, but there's a PR on the site there to add them. But everything else is there. You have how to add your data, how to get it back again, and various examples and reference materials and all that stuff. If you end up finding yourself confused at any point, please raise an issue on the docs site, by the way, and we'll try to clear that out. And yeah, so today we're going to be talking about this example app that I wrote called, imaginatively titled Example Forum dApp. It runs with no backend service, and it stores all of its content for the posts and comments and so on using Web3.storage. So I'll do a really quick high-level overview of what that looks like, sort of how the system works, and then we'll just start digging at some code, and I can ramble on about it for a while. So here's the main interface for the smart contract. It's a Solidity contract, and you can add a post or a comment by giving it the CID, which is the IPFS content identifier, in this case, it's a JSON file that describes the post or comment. And then for comments, you can also give it a parent ID of the post or comment that it is attached to. So then you can fetch an item. Posts and comments are both items by its ID. You can vote for one, giving it like an upvote or a downvote, or resetting your vote to 0 if you want. And then you can get the score for a post or comment and the sort of author karma, like how many votes that particular author has gotten for all their content. So cool. And then we also have, so this is the item structure that gets stored on chain to describe every item. It's storing maybe a little bit more than it actually needs to, just for ease of use, but it could be optimized a little bit. So basically it just tells you, is it a post or a comment? What is its unique ID? If it has a parent, what is the parent ID? And posts always have the parent ID of 0, so it's pretty easy to distinguish them from comments. And then you have the address of the author, when the thing was created, and then this array of child IDs, which is one of the, I think that's could probably be omitted if you were to optimize things a little bit. But then most importantly, perhaps, is the IPFS content ID for the actual post content, because you don't want to store large arbitrary strings of data in Ethereum unless you are Vitalik, perhaps, but even he has more sense than that, I think. But generally speaking, it's super expensive to store data on chain. Usually, no matter which chain you're talking about, there tends to storage is at a premium because it has to be globally agreed upon by all the participants and all that jazz. So we like to store things off chain, and IPFS is our preferred solution for that because it gives you this awesome immutable content ID that will always point to the same piece of content. So since you can't change the blockchain state easily or cheaply, it's nice to have a self-verifying link to off-chain data. So that's what IPFS gives you. And with Filecoin, you get that long-term persistence, sort of making sure your data never goes away and it's always available on IPFS. And so then one more thing to mention about the contract is that when an item is created, we emit this event, and it has the item ID, parent ID, and the author address. So right now, this is being used to populate the feed of recent posts, because you can just query for items with parent ID equals 0 to get you all the posts, and then just walk back the event log until you have enough posts to render your feed. But you could also pretty easily use this to replace that child IDs array that I showed in the item struct, because you could then query for the parent. Like if you know the post ID, then you can say, give me all the items whose parent ID is that post ID. So that would be a way to save on a little bit of storage state. Yeah, so then the web 3.storage comes into the mix when you're adding things. This is basically the web 3.storage interaction point. There's only really one method call to web 3.storage in the app, and that's to add this JSON data into the into IPFS and Filecoin. So it's pretty simple. It just stringifies your JSON object, adds it as a file of UTF-8 data, and then calls the put method on the web 3.storage client. And when I actually call this, I am setting, there's a option that is sometimes confusing for new web 3.storage users. We're trying to clarify this a little bit, but by default, it will wrap your content in an IPFS directory listing. So the CID you get back from put is the CID of that directory. But for simplicity in this application, I decided just to not wrap things in directories. So the CID you get back points directly to the JSON file. And I'm doing this because I don't care about the file names. The reason we have that default is because, generally speaking, humans like human readable names, and putting things in a directory lets you reference things by an actual file name. But since this is also application internal data, I decided, yeah, I'll just reference things by their content ID, which is that sort of gibberish looking string that comes back when you add things to IPFS, and how you locate them again. So when you add things, when you call this function, pass in an object, and then we'll store things in web 3.storage for you, get you back a CID, and then we invoke the contract function call. So all that good stuff. So I'm going to just go ahead and run the app, and hopefully everything works. Demo gods. But then either way, we'll go and take a look at the code and see, what all of the fancy tricks I used along the way are. And even though this talk is ostensibly about web 3.storage, like I said, the actual web 3 storage integration is super small. So mostly probably going to be talking about, the dApp architecture and how things are wired up and all that stuff. So at any rate, let's check it out. So I'm going to page over here. This is my VS Code where the source code is checked out already. And I'm over here pretending that I've just cloned this repository. So first I would npm install my dependencies. This should be a little bit slower your first round. I've already done this, so hopefully everything is cached. My home internet is too slow to leave such things to chance and do it live. But once all this stuff gets installed, you'll have everything you need to be able to run the project locally. I haven't yet deployed it, although we're probably going to deploy it to a testnet pretty soon, so people can actually play with it and make posts and so on. But so what you do to run locally is say npm run dev, and that's going to start a local, mock chain or whatever. It's like a little JSON RPC node that pretends to be Ethereum, and then it'll also start a little React web app to talk to it. So I'm going to go ahead and open this local host address in my browser over here, and you'll see Web3 news. Hooray! There's nothing here yet, and we're not logged in. I'm going to, to see something here, I have a little script here that adds some sample data. So if you run the seed script, it'll just stuff some dummy JSON into the into the contract for you. So you can, there we go. So that if we click on something and get to the detail page, we can't comment unless we're logged in. So to do that, you connect your wallet. So log in with MetaMask, let's say. I'm probably gonna have to dig my password out here. Put that. I wonder why it's spinning. It doesn't like me. Oh, Let's make sure everything is actually running here. Yeah, blockchain's running. Let's try that again. Oh, you know what? Sometimes this is, yeah, there we go. It just needs my password, so sorry about that. I have to dig it out. MetaMask. There we go. And then, yeah, connect with MetaMask. I'm going to use this testing account. It's a really good idea to use separate accounts for your actual, Ether, if you have any, and for testing, because Ethereum uses you can use the same key on multiple networks, but if you don't pay attention to which one is which, you might make a costly mistake. So make a testing account. It's free and easy. So there you go. And I'm going to say connect. And connecting your wallet sort of logs you in. So now, hopefully, it should redirect you, but I think because it had that little error, it got a little confused. So now you can see I'm signed in. I haven't added username support yet, so it's just your account in hex. And then I don't have any money yet, so but because I'm in local dev mode, I've wired up this little faucet link. So you click this, and it will make a little transaction to send you some Ether. And one kind of tricky thing to note, since MetaMask sometimes gets confused, if you've been running with a local blockchain before, and then you quit the local dev chain and start it up again, MetaMask still has like your old state information from the previous round, and it will get out of sync. So if that ever happens, you'll see like weird transaction errors. You can clear that up by going to your MetaMask account and going to settings, advanced, reset account, which sounds very scary, but actually just clears out this transient state. And basically it just forces MetaMask to ask the blockchain again, hey, what's the state of this account? And then everything will work again. So you might want to do that if you get those cryptic errors. But anyway, I now have like 1/10 of an Ether to play with. And using that, I can vote on stuff. Now it has 1 point, but I haven't actually implemented sorting by votes. They're still in the same order here, but one thing at a time. And then also, if I want to, now I can add a comment. Oh. And comments, again, require gas, so you have to authorize another transaction. And boom, now I have a comment. And then, yeah, same with posts. Now that I'm logged in, I can submit something here and say, yo. And all this basically, it's a two-step operation where it'll first add the post content to Web3 storage, use the CID to create the transaction, and then ask you to sign it. So there we go. And now, yeah, it shows up in the feed. So that's about it. That's like all the functionality so far. And then let's look behind the curtain and see what's going on. Here you can see all the various contract calls in the output of the local development chain. So a bunch of calls to get item and get score and stuff like that. The contract itself, so inside the repository here, there's two sort of sub packages. There's packages/contract, and that is a hard hat project, where a hard hat is a Ethereum development framework and handles things like compilation and deployments and all that stuff through a very nice system of plugins. So I have forum.sol, and I'll just walk through it. The main item struct. First of all, I'm using this ABI coder version 2 because I like it. Basically, it lets you pass in and return structs from Web3 or Ethers.js, or basically return a struct from a function where otherwise you'd have to pass or return a bunch of tuples and reconstruct things later. Anyway, it's very nice, and it seems to be stable now, and there's no scary warnings when you enable it, so that's great. So anyway, I have this an item has a little post or comment flag, so you can tell which is which. It has an ID. I think we saw this before. Here's how I'm keeping track of the votes. Since I only want, each account should only be able to apply a single vote to each piece of content. Every piece of content has this vote state where you map like the hash of their address to what their vote value was for that particular content, whether it was up or down, and it's 0 if they haven't voted yet. And then here, every time someone votes, we update this total for that piece of content. So, this will always reflect the latest sum. We have one ID named IceBase. So there's one counter that we use for all the IDs for posts and comments. And then here's our mapping for each ID, that's the vote state. And then for each author, this is the total score that they've received for all their content. And then here we have the main item storage. So every time you add an item, it will put it in this map using the item ID to the full item struct. So that's how you can retrieve an item later. And then this is the event that gets emitted. So here we are in add post. Since the post doesn't have a parent, all it needs is the content CID. Give it a new ID. I like to increment our counter. The author is always whoever sent the message. And then, we create this empty child IDs array. Although, like I said, I think I'm probably going to get rid of child IDs and use events instead later. But anyway, now we make this item struct and stick it in our mapping and emit that event. And that's basically it. It works the same for comments, except comments also have a parent ID. And here we can fetch it again. It'll yell at you and fail if no item exists. Right? Oh, because we have the child IDs, there's one extra thing with comments where we'll go find the parent item and add the ID of the child into that comment IDs array here. So that's not ideal. I think the reason I want to move to events is just because there's no reason to store these IDs twice on chain, basically. But anyway, here's voting. It'll check to make sure that the value is correct and that the item exists. And then it'll see if you already had an old vote and you're trying to change it, then it will first basically subtract your old vote from the total and everything and unapply it and then apply the new one. So the upshot is that you can only, if you voted up, you can replace it with a down vote or a 0, but you can't vote up twice or down twice. And then here's just the getter methods for getting the scores. So that's the contract. It's not too crazy. One thing that I will mention that's kind of nice, since I'm a TypeScript-y kind of guy, when I have the choice, I wired this thing up called TypeChain, which there's a plugin for Hardhat. It's pretty simple. You just, sorry. I can't remember where it's configured here, but at any rate, adding TypeChain to your Hardhat project will generate TypeScript types for all of the contract functions. So then basically it outputs these type definition files. So instead of just having generic contract, you can say like my forum contract .add post, and all the type completions and stuff work out for you and everything. So that's kind of cool. So anyway, when you do compile the app and deploy it, there's this deploy script with a typo in the name that it's really simple. This is a deploy plugin for Hardhat. So you just sort of describe what your deployment looks like. And when it runs, it will create this deployment info JSON. And I've also in packaged JSON set it up to where whenever you deploy, it exports everything into the web app source code. So because our front end needs to be able to find the contract, once it's been deployed. So we write out a JSON containing the address and the contract API and everything. And this actually contains like all deployments that you might have made. So if you do end up deploying it to testnet, it'll have the testnet deployment. And then if you deployed it later to mainnet, it would have that one so that your front end could switch between them if need be. So anyway, this file isn't checked into the repository, but it's generated when you deploy the contract there. And then in order to, one other thing I'll mention is that if you're not using the main run dev script from the repository root, you have to make sure that that file exists, that basically that the thing was deployed before you start the web app. The dev script will wait for it for you, so you don't have to think about it. But if you're tinkering, you might get an error if that file hasn't been generated yet. All right, so back on the web app, right? So we have I've wrapped the contract API with this sort of higher level thing called the forum API. This is what the actual UI code interacts with. The UI code doesn't really ever like make Ethereum transactions or use like the actual contract interface. Partly because I may eventually want to port this to a different blockchain, but mostly because like this gives you like one facade that ties together the contract interaction and the off-chain storage with Web3 storage. So you can just have one like add post interaction, give it a post object, and then this thing will add the content to Web3 storage and make the transaction and so on. And there's actually 2 contract instances that this thing has. So the reasoning behind this is you want the app to be usable even if you haven't signed in with your MetaMask wallet. So the way it works is as soon as the app loads, it'll use a network like JSON RPC connection to a node. It's just the local development node when you're running locally, but assuming this were deployed, you would have like an Infura node or some other hosted node with no signing keys attached, just like a read-only node. And this is used to like actually populate the UI and do all the read-only stuff. And then the authorized contract, it's connected to the same deployed contract, but it's connected through your MetaMask wallet after you log in. So this one has the ability to sign transactions and so on. And it can be undefined. You can create a forum API instance without one, in which case authorize, like anything that requires a signing key will just throw an error. But you can check, you know, do I have the authorized instance with this like can vote, can post stuff. Yeah, and so that's basically it. It's like you have the read-only contract, authorized contract, and a Web3 storage client. And this can actually also be undefined for reasons I'll mention in just a sec. But basically, if you don't have the client, you can still vote on stuff, but you can't post. So yeah, here's an example of actually adding stuff. We store the item content using that store JSON thing I showed earlier. And then this thing will throw if we don't have the authorized contract. If we do, we can call add post on it. And like I said, we have those type chain types, so you can kind of see, you know, this is like defined on the forum contract, but it kind of feels like a regular JavaScript or TypeScript method. It's kind of nice. And then, yeah, we try to, so once we've posted something, we'll try to scrape the events from the transaction to get the ID out from that new item event, and then return it to the caller. And it does this for all the, you know, the contract functions. And then here is something a little bit more complex, where we're populating the recent posts feed. I'll probably end up tweaking this at some point, but basically we're fetching like 20 blocks worth of events in one go and trying to get as many posts as we can by querying for new item events with a parent of 0. So that's meaning a post. And then once we have enough to hit the user's requested limit, or we've reached like the beginning of time at block 0, then we bail out and return whatever we've got. And here's my little note to self that if it were deployed on testnet, you wouldn't want to go back all the way back to block 0, but just to the block where the contract was deployed, because there's not going to be anything before that. All right, so then, yeah, this is add the comments, get the comments. This hydrate item thing is like, because when you've got an ID contract, you have the CID, but you don't have the JSON content yet. So this will go and fetch it from IPFS for you using this .get JSON. But I also keep like a little in-memory cache of, you know, CID to content. Since these things are immutable, it's going to be the same. There's no need to request it again. There's probably clever ways to do this, but this is just an in-memory map to store anything that we've received or successfully added. So it makes the user interface a little snappier. And then, yeah, this is voting for stuff, all that stuff. So this is just wrapping the contract functions, basically. Here's storing the JSON and fetching it again. For fetching, I decided, I was originally calling the get method on the Web3 storage client, but then later I made it so that you might not have a storage client. And then in that case, so since fetching doesn't require like an API token or anything, and you can fetch from any IPFS HTTP gateway, I decided to just use a regular HTTP fetch request to fetch the JSON through the dweb.link public gateway. Just, in case I don't have the client handy at that moment. All right, so then why wouldn't you have a client? That is because one thing I didn't really show in my quick demo is that I've added my web3.storage API token to the app, and this is stored in the browser's local storage, because I'm trying to avoid bundling my API token into the front end where anybody could grab it. So this is not an ideal solution. We're actually working right now on public key-based authentication. So you could sign a small message with your Ethereum key, prove ownership of it, and we'll basically use that as your identity. So as you can imagine, there's details to be sorted out there. So we're trying to do it pretty deliberately and not box ourselves into any corners and so on. So until then, the options for protecting your token are basically ask each user of your decentralized app to provide their own token. It's probably not the ideal flow. Or you could proxy things through a service that decorates the requests with a token. And we're also, in addition to the wallet auth, we're thinking about sort of deferred token, or not deferred, but like scoped tokens that are issued on behalf of someone of another account. So you could have like your dApp account give like a token with limited privileges to a dApp's user. So that story is still evolving. But for now, we have this thing where if you don't have one of these and then you try to submit something, it'll just redirect you back here and say, hey, paste in a token. So in that case, since I'm logged in, I can still vote on stuff, but I don't have the ability to add stuff to Web3 storage. So yeah, that's not the greatest, but like I said, stay tuned and we will hopefully have answers to satisfy you all. And then, yeah, other stuff that might be interesting. I mean, a lot of it is really just, here's like some data modeling. In a real dApp, you might do things a little bit differently, but I'm trying to, give this example. I feel like it is just real enough to where you can like extrapolate out to your use case and say like, okay, the specifics might be a little different, but referencing data off chain will work in largely the same way and all that stuff. So yeah, the UI stuff is all in the components directory, but I'm not really going to get into it too much because it's pretty standard React stuff. One thing that's maybe not quite so standard is the query interface. So I'm using a pretty cool library called React Query, which is it's sort of a caching layer for that's doing it a disservice, but basically like it gives you nice like context and hooks-based API for asynchronous operations, and lets you like key them by a specific key, and then it'll keep track of that value, and you can invalidate things as new information comes in and so on. So it's a little like, you have to think about it a little bit, and you have to, maybe if you've never used it before, you might want to read the docs, but it's not that complicated, and it just makes the data flow a little nicer. And so what it does really too is just, it stands in front of that forum API instance, and all it does is call methods on the forum API basically. But by having this extra layer in there, it makes things a little bit more responsive when nothing has changed. And yeah, I think I'm running pretty close to time here, so I'm gonna wrap it up. And yeah, I'll stop sharing my screen there. But if you guys have any questions, you can email me. I'm Yusef at protocol.ai, or even better is hang out on our, we have various support channels that you can find in the docs site. So if you go to the docs site, docs.web3.storage, and click on contact us, it'll take you to the correct Slack and or Discord or whatever chat channel where you might get a faster response than if you were to email me directly. But I will try to respond. I'm kind of a little snowed in sometimes and takes me a minute, but I do like hearing from people that are using the things, especially if you're having issues with it, because we won't know unless you tell us. We are aware of some rough edges, and especially the token stuff that we're working on. But again, like we don't know necessarily what your needs are until you let us know. So thanks very much. And I think that's about it for me.